Hi, I'm Chris Lambert, and welcome to my FME World Tour presentation. So today I'll be talking about simplifying MCA projects, so multi-criteria analysis, and how we've used FME to simplify and automate some of our processes around these projects and our workflows. So I'm sure a lot of you have done MCA multi-criteria analysis before, especially if you're a GIS analyst. You might not have come across them if you're using FME for different work processes. But we do quite a lot of them at Jacobs, where I work, for a wide variety of clients. So we have like a rough five-step process that we follow when we need to do a multi-criteria analysis for either internal clients or external clients, depending what the requirements are. So it's quite a good multi-criteria analysis is quite good in terms of combining lots and lots of data sets, especially GIS data sets, and getting a different result depending what you need. So the first step, I'll go through this quickly because I'm sure a lot of you are very comfortable with this, is defining what you need to do and what the problem is you need to solve. So whether that's for bushfire risk assessment, deciding where to put a new power line, deciding where to do cultural heritage field work or do a ecology assessment, defining what you need, the problem you need to solve is the first step. Then you go away, determine what data you need, whether that's topography data, wetlands, demography data, planning, imagery, and all the rest of it. As you know, it's quite easy to get a lot of data now, but getting a lot of data obviously makes it more complicated to define what data you need, because you can easily get too much data. Then the next step is integrating it all. So this is probably the most complicated step, and where we've sort of our FME process for this presentation has made some really good improvements in our workflows. Is this integration step? So deciding what data you need and how to filter down that data. So sort of what queries you're going to run on the data as your SQL queries, how you're going to intersect your data, how you're going to buffer it by a certain amount, and what that means for each criteria. So we break it down to different criteria layers that we call it, and each criteria layer has a different score depending on sort of what project you're doing. But for most of our projects, it's kind of like importance. So the waterways might be really important for a certain type of assessment. Certain planning layer might be really important. You give that a higher score. You filter it down, and that creates your criteria layer. And then you run the assessment, so that clips all your data, buffers it all, intersects it between each other, and you get a result. So a lot of the time we use a summation approach. So you sum all those criteria layers together, and the area with the highest score might be the most important. But you can also do an average, a maximum, a minimum, depending what assessment you're going to do. But all the time you're adding scores together with those individual criteria layers. And then the last step is to communicate. So this is a pretty obvious step, but it's a really important step, especially if you're working with clients that aren't familiar with MCA processes. I mean, in terms of the technical analysis, it's not that complicated. You're just buffering, clipping, and adding layers together at the end of the day. But in terms of when you're getting lots and lots of data layers together, it can get complicated fairly quickly. And you need to communicate that well to the client and what your results mean. So how we did these assessments previously. So we did have some FME workflows previously. So previously built by some other people, including Darren, which I'm sure some of you might know, FME whiz at Jacobs. But there was a little bit of a missing step before our existing FME process in terms of pre-processing some of the data. So making those individual criteria layers. We had a process for adding those criteria layers together, but a little bit of a missing process in terms of the pre-processing steps. So especially forming those individual criteria layers. So that involves intersecting them to make an individual criteria layer, running definition queries, so SQL queries, dissolving those layers, and those steps there. So we previously did it all through Arc Pro, which is totally fine, really good for visualizing each individual step, and it is really good for building up each stage of the assessment. So we still use some of that to build our queries and sort of visualize the data. It's definitely the best tool, I think, for that sort of step. But there was quite a few issues in doing this process manually, which I'll cover now. So I suppose the main issues we had is it wasn't easily repeatable. So when we clipped the data, when we buffered the data and made those individual criteria layers, that was all done through Arc Pro, and it was really hidden within each query and with each layer that we made in our within our geo database, which was fine if you're doing it once, but it became really complicated and very slow if we had to repeat it. And there was a lot of reasons why you might want to repeat it. The main one is if the criteria change. So especially when we're working with our specialists, so with our ecologists or cultural heritage or engineers, and they go, oh, okay, this result doesn't really make sense. We need to change some criteria. Or the client has client comes back with a different requirement. We had to then go rebuffer, reclip, rerun these definition queries, and you can obviously see this snowballs and it's quite slow to repeat if you're manually clipping, buffering, and running each one of those tools manually on each single layer every single time. So yeah, you can see how it becomes quite slow and arduous when you have to do that manually. So it also meant it wasn't really traceable. So each of these definition queries, they were hidden in your Arc Pro session, and you couldn't really see each SQL query. I mean, we kept a catalog of them in a Excel spreadsheet that we just sort of was a catalog. It was just for visualization, or in like our Word documents in our project documentation. But that didn't feed directly into our processes beforehand. So it was really hard to like kind of know how each of your layers were grabbing certain layer types. So for example, in this screenshot here, like, okay, which EVC environmental layers were being filtered down for this individual criteria. And it was, really hard. It was really hidden in the processions. So it wasn't really traceable of like what the analyst has done to get a certain result. And the same with like buffering and clipping and intersecting. You're running those tools individually, and we made project documentation in a Word doc, but obviously that's like a lot of work to do at the end of a project. And you're like, oh, okay, how did I buffer this layer? How did I clip this layer? It's kind of a bit hard to memorize, especially after when you've got really tight project deadlines and you have to make all this documentation as well to try and remember how you've clipped and buffered and all these different layers. So yeah, you get bogged down in that documentation. You can get lost, and there's a lot more room for human error there. And the last one was like, it was quite hard to hand over to a new analyst. So you've gone halfway through this project and you need to go on another project, or you're going on leave. It was really hard to change it, really hard to hand over to another analyst if you've clipped or buffered or different things in different ways. So yeah, hard to hand over as well. So we built it better in FME. So made a workbench, made a workspace, nothing really that complicated. It's just clippers, buffers, filters, SQL queries. And then we made an Excel spreadsheet to input all our requirements. So it was based off a previous FME workflow that as I said previously, but the previous FME workflow didn't include SQL queries and didn't include making these individual criteria layers. So I'll just go back. So you can see here these individual criteria layers. So this is like 100 meters from a lower order stream. Built into the input is the SQL query, the buffer, what it's scored, and how it interacts with other layers, and how it's clipped by other data inputs as well. So this was done like just in a Word doc sort of in a format. but we wanted to make it actually into the spreadsheet, which goes straight into our actual workflow and actually goes into the data. So there's not that double up of work and input, which we found really handy. So the requirements we needed was, sort of works with our previous workflows. Another one for a certain project, we needed a vector polygon output rather than a raster. So the new process we built does both, and that was just for a certain requirement. But obviously, you can kind of see you have a little bit more flexibility in terms of your outputs. If you've got a vector, it can feed into certain mobile mapping workflows a little bit better. Vectors a little bit lighter data sets, as a lot of you probably know. So it has more flexibility in terms of that. And we also built it with the intention of being run by analysts that haven't used FME before or not comfortable using FME. So all you have to do is open the Excel spreadsheet, input your queries and how the data is manipulated, and then press run on the bat file. Super easy. And analysts who have not used FME before can just click run and it's good to go. So the individual steps, I'll just go over quickly here. So creates individual criteria layers. So runs the SQL queries, combines the data sets, clips, buffers, intersects, and allocates a score. So that's done in step 1, which I'll go over in a little bit. Step 2 combines them. So a lot of the time we add those individual layers using the sum function. That's 99% of the projects that I've done. But you can also do a max min average as well. And then that creates individual polygons of a certain score. So you can go into your visualization software, whether it be ArcPro or ArcMap Online or QGIS, and click on a polygon and it gives a certain score based on your assessment. And then it also creates a raster output as well, depending what you want for your project requirements. So the main beast is the input spreadsheet. As I said, the analysis is nothing complicated. This is not really a whiz bang FME process with lots and lots of transformers and very, very complicated. It's a pretty simple sort of thing. But in terms of simplifying our workflow, it's been really, really useful. So just being able to look at sort of one spreadsheet with a few different tabs, but the main tab being the input tab, and just having all your SQL queries, how you're clipping, how you're buffering in one sheet has just been super useful in terms of visibility and traceability for how our assessments are done. And this input spreadsheet feeds straight into the FME into the workflow. So it's not just a documentation piece, it's a documentation piece and how the analysis is actually done. So this allows us to actually then put more effort into working with the specialists and the clients of like how we do the assessments, rather than just sort of doing documentation and rerunning workflows, because the time of rework has been cut down quite a lot, and so it can put a lot more effort into actually making these assessments sort of more useful to the end client, and actually putting a little bit more thought how like each of these criteria is built and what the result is that we want. So you can see here like how these layers are going to be clipped, SQL query straight in, what data set is coming from, and you can have 3 input data sets and like 3 clipping data sets, and you can do intersects, buffers, clips, depending on the different settings. So really big advantage that we've got. So fairly simple FME workspace, just clippers and buffers, as I said. But it did get a little bit complicated in terms of the clippers, especially when you're wanting to clip by multiple clippers. You want like a cascading. I thought it was going to be like quite easy to build, but in terms of like that cognitive challenge to work out which clippers go in front of other clippers, got a little bit challenging. We worked it out in the end, and working out defining sort of what clipping is and what intersecting is with different data sets was quite important, not in terms of actually building the FME workspace, but also defining like what we want for a certain criteria. Do we actually want one layer where it intersects with multiple layers, and we want each one of those polygon intersects, or do we want to get a polygon and clip it down smaller and smaller and smaller by multiple other polygons? So that is probably like when you're actually filling out the spreadsheet, that's the hardest bit to sort of think about, even though it's a relatively simple concept, clipping and buffering and intersecting. Once you start getting multiple data sets intersecting with multiple other data sets and intersects on intersects, yeah, it can get quite complicated in terms of working out. Cool. So some of the big advantages is, as I've said, you get much better visibility to queries where it's in that spreadsheet rather than hidden in your ArcPro sessions. Can be easily altered and repeated, and can be easily handed over, as I've said. So there's still some issues in our workflow. Big one is donuts. So when you're resolving complex polygons with lots of vertices and holes within holes within holes of polygons, the clipping transformer can slow down a bit. I think in the latest versions of in FME I think that transformer has been upgraded and is a bit faster, but I have found better clipping speeds with ArcPy for certain like complex polygons. But overall, FME is still a lot better for an overall process. So I suppose you might ask why I wasn't built in ArcPy. I think in terms of having like a workflow for multiple analysts across the whole business, FME is definitely better in terms of a learning curve especially for other analysts who might not have programmed in Python before. FME is a little bit easier to edit and edit the transformers and edit it as needed compared to ArcPy. And we can like easily run it on FME server and stuff as well, which is quite good, which we have. So there are some other limits as well. Only the workflow that I built was only limited to 3 inputs and 3 clippers, which we have sort of found for some requirements is a little bit restrictive, but we've kind of got around that with feeding inputs to other inputs and stuff. But is something we can definitely work on. And as I kind of said previously, understanding the input spreadsheet is still a little bit overwhelming, especially when you're working out like what needs to be clipped by other data sets and clips and intersects and intersects. Is kind of a little bit hard to figure out, and it is kind of good to maybe definitely visualize it in ArcPro as well before you put it into your spreadsheet, because I definitely need to work with some visualizations when you're putting those queries into the spreadsheet. So yeah, it is still a little bit overwhelming, and we could probably work on making that a little bit more simple to understand as well. So that leads into some improvements that we could work on. We can connect straight to our like SQL databases as well for data inputs. Currently, we just go from geodatabases and shape files and raster inputs as well if we have them. I need to make some better documentation. That's a classic one for any technical workflow, just so other analysts kind of know how to pick this workflow up and run with it. And as I said, greater flexibility for the number of inputs as well. Could probably work out maybe a little bit better process to do that rather than just having 3 inputs, 3 clippers. Probably a smarter way to do that. And then also, greater filtering before you get to those clippers. So as I said, the clippers can be a little bit slow when there's complex polygons. But yeah, so might probably need to maybe work out a smarter way to do some better filtering. But yeah, and yeah, that's it. Thank you for my presentation. Relatively simple sort of FME workflow, but it's definitely sort of improved our processing for MCA projects. And yeah, it's definitely a good tool that we use all the time. Thank you.